Analysis of frames. That is the topic we are covering. It is a new topic, the last topic in structures, module 1. Now, a frame is analyzed by 3 methods. One of the methods of analyzing a frame is a method we call method of joints. The second method we call it method of sections. And the third method is known as the graphical method. Now, in this topic, we are going to be considering 2 methods of analyzing frames. That is, the method of joints and the method of sections. And we are going to begin with the method of joints. Now, we have a problem to solve and also to see how we apply the method of joints to analyze a frame, a perfect frame in this case. Now the question is, find the forces in the members A, B, A, C, as well as B, C of the truss that is shown in the figure below. Now, this truss is a simple truss, and we say that the simplest frame is a triangle with 3 joints, that is joint A, B, and C, and 3 members A, B, A, C, as well as B, C. Now, at joint A, this frame is subjected to an external load of 20 kilonewtons. Angle ABC is 60 degrees, angle ACB is 30 degrees, definitely making angle BAC to be 90 degrees, and therefore we are dealing with a right angle triangle. The distance from B to C is 5 meters. Now, the first thing we are going to do, we are going to determine or to calculate the length of member AB, and therefore member AB will be equal to, or will be given by 5 cos 60. Why 5 cos 60? Because we can consider member AB as the adjacent and BC as the hypotenuse. And we know very well that cosine of theta is given by adjacent divided by hypotenuse. And the length which we are looking for is the adjacent, that is AB. So in short, we can say that cos theta is equal to member AB, or length AB, divided by BC, which is the hypotenuse in this case. And therefore AB is going to be given by BC, and the length of BC is 5 meters. Therefore 5 multiplied by cos theta, that is cos 60 degrees, and therefore the length of that member is going to be 2.5 meters. 2.5 meters. Therefore that is the length AB, 2.5 meters. Now from there, we are going to determine the distance of the line of action of 20 kilonewtons from B. Therefore, distance of line of action of 20 kilonewtons from B, that means that let's call this point E. Therefore, the length of member BE, or that distance BE, where 20 kilonewtons is acting, its line of action. And That is going to be given by, therefore you can say that BE will be given by 2.5 cos 60. 2.5 cos 60. And that's going to be 1.25 meters. Therefore, the line of action of 20 kilonewtons from B will be 1.25 meters. This point here, B to E, 1.25 meters. Good. From there, we go to reaction calculations, okay? Reaction calculations. So we are going to determine the value of reactions at B as well as at C. This means that this truss is supported on members B as well as C. Now, these two members, they can either be columns, they can be walls, they can be beams, whatever members. Now, for us to get the reactions at B as well as reactions at C, we are going to take moments about B. And therefore, we are going to say this, taking moments about B, we are going to have the following. We get, now, this is going to be RC times 5. The distance from C to B, that is 5. Therefore, we are going to have RC times 5 being equal to 20 times 1.25. Remember, the sum of clockwise moments are equal to sum of anti-clockwise moments. Anti-clockwise moment, RC times 5. Clockwise moment, 20 times 1.25. Therefore, RC times 5 is equals to 20 times 1.25. Therefore, this is going to be RC being equal to 20 times 1.25, divide this by 5. And that is going to give us a reaction of 5 kilonewtons. Therefore, the reaction at C is going to be 5 kilonewtons. So you can write it there as 5 kilonewtons. We need the reaction at B, and we know very well that the sum of upward forces is equal to sum of downward forces. That means that when you add RB to RC, you are going to get 20. Therefore, RB and RC, those are upward forces, and a load of 20 kilonewtons at A, that is a downward acting force. Now, we already have the value of RC, which is 5 kilonewtons, and therefore we are going to have RB plus 5 is equal to 20. That's going to be RB being equal to 20 minus 5, which in this case is going to be 15 kilonewtons. Therefore, the reaction at B is going to be 15 kilonewtons. Now, after getting the reactions at the two supports, the next thing we are going to do is to analyze the equilibrium of various joints. Therefore, from there we go to analysis of the equilibrium of various joints. Equilibrium equilibrium of various joints. Equilibrium of various joints. Now, in our frame here, we are going to consider two joints, that is joint B as well as joint C, so that we determine the forces acting on members AB, AC as well as BC. And therefore, we are going to begin with, let's begin with joint B. So we begin with joint B. Now, when you consider joint B, we have member BA, that is A, whereas that is B, and then we have C on the other end, and then at B we have a support, and the reaction on that support is 15 kilonewtons. Now, the angle here, ABC, is 60 degrees. If we assume that we have a compressive force on member AB and call it force F1, then on member AC we have a tensile, we assume that we have a tensile force of, or we call it F2. Now, we are going to determine the vertical as well as the horizontal forces acting on this joint. And let's begin with resolving the forces, vertically, and applying the principle of summation of vertical forces equal to 0. Now, we are going to have F1 sine 60 plus 15 kilonewtons, that's going to be 0. Now, why are we getting F1 sine 60? This is a slanting force, and when it is acting vertically, we have an angle of 60 degrees here. When it's acting vertically, it's going to be given by F1 sine 60. Even if you consider this part here, consider that by part. This is opposite. This is hypotenuse, where we have the F1. So, when you want it to act vertically, we are going to have sine 60 being equal to what? Opposite, which we are looking for, divided by adjacent, which is F1, and therefore the opposite will be given by F1 sine 60. So that is a vertical downward acting force plus vertical upward acting force, that is the reaction at B, which is 15 kilonewtons, being equal to 0, applying this principle of summation of all the vertical forces being equal to 0. And therefore, we are going to have F1 sine 60 is equal to, we bring 15 this side of the equal sign, that is going to be negative 15. So to get the value of F1, we are going to divide through by sine 60. Divide through by sine 60. and therefore the value of F1 is going to be negative 17.32 kilonewtons. Now, what does this negative mean? This negative means that the force is compressive. Compressive forces are negative, tensile forces are positive, and therefore this force F1 is acting towards the joint B. It is compressing the joint B. Good. From there, therefore you can say that F1 is equals, we assume or we ignore the negative 17.32 kilonewtons into bracket, that is a compressive force. Good. Then from there we have resolved the forces vertically. Let's now resolve the forces horizontally. Therefore, resolving the forces horizontally and applying this principle, summation of all horizontal forces being equal to 0. Now, horizontally we are going to have F1 cos 60 plus F2 is equal to 0. Now, horizontally, like that, that's now where our F1 will be coming to, and therefore, since we want it to be on the adjacent side, so we have adjacent, and then we have the hypotenuse, and we know that that relation of adjacent and hypotenuse is a relation of cosine, and therefore F1 cos 60 horizontally will be that is plus F2, another horizontal force, is equal to 0. Now we have the value of F1, which is negative 17.32 kilonewtons. Therefore we can bring it at this point. So we have F1 negative 17.32 kilonewtons multiplied by cos 60 plus F2, that is going to be 0. Now this is going to, or we are going to have negative 17.32 cos 60 being equal to negative 8.66. Therefore negative 8.66 plus F2 will be equal to 0. Now bringing negative 8.66 this side of the equal sign, we are going to have F2 is equal to 8.66 kilonewtons, and therefore that is the value of F2. And being positive, it means that this force is tensile. That means that it is acting away from joint B. Therefore, F1 compressive acting towards joint B, F2 tensile acting away of joint B. From there, we are going to consider joint C and resolve the forces that are acting on member AC as well as member C to B. So after we are done with joint B, we now go to joint C. Joint C. Now, when you consider joint C, we have we are going to have it like this. Yep. This is B. This is A. We have an angle of 30 degrees. This is C. And then at C, we have a support with a reaction of 5 kilonewtons. newtons. 5 kilonewtons. Now, on member AC, let's have a force acting on that member. A force, we are going to call it F3. And let's assume that the force is compressive. On member CB, we are going to have a force F2 acting on that member. Now, resolving forces vertically, and applying this principle of summation of all the vertical forces being equal to 0, we are going to have F3 sine 30 plus 5 kilonewtons is equals 0. These two are vertical forces. This is a downward acting force that is being subjected at joint C, whereas this is an upward acting force, that is the reaction on this support C. Therefore, when you add all the vertical forces, we are going to have 0. Now, this will be equal to F3 sine 30 will be equal to negative 5. When you take 5 the other side of the equal sign, it will be negative. Therefore, for us to get the value of F3, we are going to divide through by sine 30. And therefore, when you divide 5 by sine 30, that's going to be 10 kilonewtons, which is negative. Therefore, F3 is equals negative 10 kilonewtons. And this force being negative, it means that the force is compressive. Therefore, our assumption of a compressive force on member AC is correct. Therefore, F3, that is a compressive force. Let's now resolve the forces horizontally. We are done with vertically. Therefore, resolving the forces horizontally and applying the principle of summation of all the horizontal forces being equal to 0, we are going to have F3 cos 30 plus F2 is equal to 0. Now, F3 cos 30 will be a horizontal force. F2 is also a horizontal force, both being subjected at joint C. And therefore, when you add the two horizontal forces, summation is equated to 0. Now, we have the value of F3, which is negative 10. Therefore, you can say negative 10 cos 30 plus F2 is equal to 0. Now, negative 10 cos 30, that is 8.66. Therefore, negative 8.66 plus F2 will be equal to 0. And that's going to give us F2 being equal to, take negative 8.66 the other side of the cosine, that's going to be 8.66 kilonewtons. And this force being positive, it means that the force is tensile. And therefore, this force again is acting away from the joint C. Therefore, ladies and gentlemen, that is how we usually calculate the forces on a member of a given truss. And in this case, the simplest one we are considering, that is a triangle. Now, we can write those forces now so that they be in order. We have F1 17.32 kilonewtons, and this is a compressive force. We have F2, which is 8.66 kilonewtons. In this case, that is a tensile force. And finally, we have F3, which is 10 kilonewtons, which is a compressive force. Compressive force. And therefore, on member AB, we have F1, 17.32 kilonewtons. On member AC, we have F3, 10 kilonewtons, compressive. And on member BC, we have F2, 8.66 kilonewtons. Therefore, ladies and gentlemen, thank you for watching our video. Please join us in our next videos that we are going to record as we continue with this topic of analyzing the frames. So please remember to subscribe as well as to hit the notification bell so that you'll be the first person to be notified every time we post a new video. Thank you very much for watching.